Hi guys, I am good. I hope you guys are good. Today we're looking at article geometry, particularly the distance formula. I will deal with this in about 3 ways, or maybe 2, I'll see. But anyway, I want us to look at calculating the distance of segment AB, right? And we'll just do that analytically, right? Without formula, yeah, just by looking at it and trying to do a few calculations. I'm sorry, this is not going to be a great exercise now because what I've done is I didn't put units here. I just gave the numbers. But anyway, think about, we're trying to calculate AB, and what we want to do, we realize AB is made by two components, AC and BC, right? If you don't understand what I mean by that, please text me and ask me when you're watching this video. So anyway, it's made by those two components, right? So yeah, anyway, let's look at this. The way I'm going to do this, it's very straightforward. So I'm going to say, let's find the length of AC. How would you find the length of AC? Right? Think about that. If you don't understand that, ask me how I would find the length of AC. Right? The length of AC would be this x value over here minus that x value. So what I'm basically saying is that if, for instance, a person had a ruler over here, and this was 0, 1, 2, 3, 4, 5, maybe 6, right? And there was someone at 5 and there was someone at 1, and we want to know what is this distance over here. We're just going to say 5 minus 1, so the biggest minus the smallest, so that was going to be 4, and it is 4 because that's 1, that gap, it's 1 unit, 2, 3, 4. So it was going to be 4, and the way we did it is 5. It's that largest number minus the minimum, or the small number there. So that's how we would do it. So that's the same thing that I'm asking us to do here. So it's just simply going to be 8 minus 4. So that length is going to be, I think, 12. And I will also ask us to calculate BC. Let me go down a bit. I would ask us to calculate BC, and BC will do the same thing. We'll take the highest, but remember, with AC, the Y value doesn't change if you look at it. So we can't use that to calculate the length. We're calculating the length in the X direction. So also here, you can see that the X doesn't change, the Y changes, so we'll use the Y. So that's going to be 3 minus 2, and that's going to give us 5. So now, what do we have? Ooh, let me see, I want a color that's more, okay, maybe that's fine. So this is going to be 5 units, and this is going to be 12 units. And we want that guy AB, right? So we can realize that what we have here, it looks like a right angle triangle. So what we can do now is to just use Pythagoras to find what AB is, right? Let's go ahead and do that. So by Pythagoras, AB squared is equal to what? It's equal to AC squared plus BC, and that's because triangle ABC is a right angle triangle, and we're using that. We're using Pythagoras. That's Pythagoras, and that's the reason why we're using it, and what we are using is Pythagoras, right? So we're gonna substitute that. We know what AC is 12, that's squared, and we basically know what BC is 5. We square that. So however, we want AB, we don't want AB squared. So we're going to take our 12 squared plus 5 squared, and we're going to give it a square root, right? I'm sorry. And then what we're gonna get is gonna be, you can put it on your calculator, but we're gonna get 13 units. It's important to say that it is units, right? So that's that. I hope you guys see. That's how we calculated the length of AB. So in grade 9, you would have gave a student something like this, and you can ask them a length of AC, a length of BC, and a length of AB. You would not expect them to use the distance formula because they do not know it, right? But after doing a lot of this, you're like, guys, you know why this reason is here, right? But I'm going to take it out of the way for some reasons and put it down there. So now you guys know distance formula, but yeah, I'm going to, this is basically where we started from in trying, excuse me about that, in trying to prove this. So I'm going to come now to how does this work in a general form, right? Sometimes in mathematics, we do things, we do them, then we want to generalize them. Sometimes we generalize them just like that, and then we use them. So we're going to do exactly the same thing that we have done in that problem, but we're going to do it in a general form. Let's go find AC. Oh, sorry. So AC would be equal to that x2 minus x1, and okay, I'm writing this in the wrong line, so it looks weird. And that's wrong. And BC would be equal to y2 minus y1. These are just the lengths, the same way I just said. You just say x2 minus x1, and then you just say y2 minus y1, right? So yeah. And then when I like, oh, we are actually interested, oh, I'm sorry, I named my triangles differently here. I named it incorrectly, so this is going to be AC. This is going to be B. My apologies. So now, when we go into Pythagoras, we have the lengths. We're going to use Pythagoras to find AB. So when we actually go there, we're just going to say our AB squared must be equal to our AC squared plus BC squared. Now, our AC squared is just x2 minus x1 squared. This is plus, then our BC is y2 minus y1 squared. That's our AB squared. However, we want our AB, then our AB is equal to what we have. Oh, sorry. X is in that plus, messing around with my colors, my apologies guys. Then that's just going to be, why is this happening? So this is going to be squared, then that's going to be y2 minus y1 squared, right? And boom, we are done, right? We are done. So now, what does this mean, right? So I'm seeing a possible misconception, right? One person could think that we need this point C to find our AB. We actually do not. If we have the segment AB, right? If we just have the segment AB in a particular Cartesian plane, let me see if I can get that. Boom. Let's see. I hope I have it. Okay, I have the whole entire thing, but it's fine. I can trim it off. I'm sorry. Okay, this is taking time. Anyway, so suppose that I fit a Cartesian plane there. Okay, it's not nice. But anyway, this can work anywhere. I don't need to know what are the coordinates of this point, which was C. I can just use that AB like it is, right? With AB, I have everything, right? And it means I have x1, y1, x2, y2. So I didn't need C. But in the developing of the formula, that's how it is. But yeah, that's your distance formula. I'll see you guys in the next video.